All right, so what we got, Andon. So, Mr. Thompson, just so you know, we're recording this for our other group, and we're going to post it on the Edmodo for the other group, okay?
Yeah, I saw the ones this morning. That's pretty neat.
So, it takes a little bit because I got to upload them to YouTube and then put them on, so it's a little bit annoying for some of the students in class while I'm trying to do all that other stuff, but just to let you know, that's what's kind of going on right now. So I'll have to edit this one a little bit. All right, so what we're working on today, growing and shrinking patterns. What we want to do is we want to identify, describe, and extend the pattern. That's what we're looking at doing in math with this section of our patterning, okay? Yep.
This one is for the 10 and go up by 5, and the second one is for the 90 and subtract by 3.
Perfect. So you are already getting them and having a look. I've designed these two examples to be fairly easy. Most people could look at them and say, okay, I've got what they are. But this question here, what is a pattern rule? So what are we talking about when we're talking about a pattern rule? Yep.
The way it goes up or down.
So the pattern rule looks at the way it goes up or down. Yep. Anyone else? Everyone's quiet because it's recording and you don't want to get it wrong. Is that what's happening now? So pattern rule, right? We say we identify the pattern in words. Okay? That's what the pattern rule is. And it always begins the exact same way. Pattern rules always begin the same way. And for this one, let's say, we say start at, what do we start at? Jess?
10.
Start at 10. In this case, we're growing, not shrinking. And so we are doing what?
Addition.
Addition. So we add, what's the number we add each time? Joe? What's this one going up by? Yeah, 5s. So start at 10, add 5 each time. Now, I should have went like this. Start at 10, add 5 each time. This is our pattern rule, okay? In this case, we're going to write over here PR. So our pattern rule equals start at 10, add 5 each time. And that's what we can see here, right? Start at 10, add 5 each time. What about over here? What is our pattern rule? Yes, Jess?
Start at 90 and subtract 3 each time.
So, start at 90, subtract 3 each time. Okay? So that's our pattern rule. We can see the rule. We can see the pattern. We can see how it goes. So we're identifying the pattern in words. And it always is start at something, and then something else happens after that. Now, whenever we are trying to work through these patterns, oftentimes we'll create what we call a T-chart. Okay? And we'll create our T-chart. And then what we want to do is we want to identify our value and our term. So here we have term. And term is often represented as n later on when we get into algebra. So I'm going to put it there right now. Term. Okay? And then we have what's called a value. So what's the value of that term? Term just means what number is it? So in this case, you have term number 1 or the first number you see in the pattern. Term number 2 second number you see in the pattern. So term number 1 is 10. Term number 2 is 15. So the term is just the number placed in the pattern. What would term number 3 be?
20.
Keegan? Huh? It's a lot of screens and things in your way, right? What would term number 3 be? Georgia? 20, right? Term number 4, 25. Term number 5 is 30. What would term number 7 be?
40.
What would term number 8 be?
45.
45. So we know that these go up by 5s. So I could actually, we could easily get to like term number 10, or, because this is pretty simple. Does that make sense to everyone? You can see here, in this case it's plus 5, plus 5, plus 5. We're going up by 5s, right? So if you weren't sure of the pattern rule, you could create your own key chart, and then you could figure out what the difference is between the numbers. Okay? Some are difference. So that's for this example here. What about for this example? We also have a term, which we represent by the letter N, and we have a value. So for this one, again, term 1, 2, 3, 4, and 5. What's the value of term number 1? Natalie?
90.
Havana, do you know the value of term number 2, the second number in this pattern?
Yes. No idea.
Yeah? 87. We got a lot of stuff going on this. Hold on as I turn this radio down. Yep. Second term, 87. Right? If we go through. First term, second term, third term, 84. Then we have 81 and 78. So these are our terms and our values. Same thing. We can look and see what's the difference. Well, here it's minus 3, minus 3, minus 3, minus 3. Now these are all fairly simple, right? Not too hard. Pretty basic examples. Later on, when we get into algebra, we're going to talk about how you can figure out how to find a term for like the 87th term, or the 51st term, or the 10th term. Because one way to do it is just to simply keep subtracting or adding, and you can find out what those are. If I was to say, what is the 10th term, or find the next 3 terms, you could do that quite easily here. Right?
Yeah.
You'd be able to figure it out because the pattern is pretty simple. Does that make sense to everyone? Okay. We're going to move from here into something that's a little bit more challenging. Not a lot, but a little bit. Okay? And I'm going to give you a different example. How many people have this example here down? How many people have written this example here down? Everyone should have it down. Keegan, do you have that one down? It's tougher to see, but this example should be down. All this stuff up here should be into your notebook, right? That's why we're putting this stuff up here, so you can have those examples, so you can go back and have a look through them. Okay? I'm going to take off our one example here. I'm going to take this off. I'm going to grab a quick picture of it right here, just so that it's there for anyone for reference later if we need it. I'm going to grab a quick picture, then I'm going to erase this one example. Okay? We're going to try a different pattern this time. Okay? So this is a bit of a different pattern. Wait a second. Hold on. Ooh, that's not right. Helps if I do that right. Does that make more sense to people?
Yeah.
People were probably really wondering about that pattern. This one. Does this one make more sense?
Yeah. So this one makes sense.
Okay, so if we look at this one, what is our pattern rule? Pattern rule equals what? Well, how do we start our pattern rule? It always starts, Josie?
Start at 0.
So, pretty simple. We start this pattern, start at 0. And then what's the next part, Georgia? Times 2 each time. Does that work? 0 times 2 is 2.
No.
So we can't multiply it by 2.
Times it. Can the pattern have 2 rules?
Does the pattern have 2 rules? Can it? Sometimes a pattern can have 2 rules, like plus 4 minus 2 or something like that. Does that work for this? Natalie, what are you thinking?
Plus 2 multiplied by 2.
Plus 2 multiplied by 2. So if we did that, 0 plus 2 is 2, multiplied by 2 is 4.
No.
So it can't be that one.
That'd be 3.
Let's break it down a bit. So we start at 0. We know for this one we do what? How can we get to 2? So let's put that in there just for right now. Add 2. And how can we get from 2 to 6? Because we can't add, if we just added another 2, we should be at 4. A basic adding or growing pattern is 2, 4, 6, 8, 10. Jess?
It's multiplied by 3. It's 2 times 3 is 6.
So at this point it's 2 times 3, but then is 6 times 3 12?
No.
So it can't be times 3, right? But we could say, start at 0, actually should be written, start at 0, add 2, and increase by, how many more do we increase it by for the next one?
4.
So it's 4. This is 2, this is 4, what's this?
6.
6.
Increase by 2 each time.
So start at 0, add 2, and increase by 2 each time. So we add 2, and then we increase by 2 every time we continue to go up. Does that make sense? Okay. If we were to write that in our T-chart, okay, we have our term as n, and we have our value. Okay? So we have term 1, 2, 3, 4, 5. What is term 1? Joe, what's the first term in this one?
2. 0.
First number you see there,
2.
right? What's our second term? Addison, what's our second term? Yeah, it's 2. What's the third term, Havana? Third term, third number is? Yep, you got it, 6. Fourth term is 12. Fifth term is 20, right? As we go through, we're going to talk a little bit more later on in the year about n and what that means for the terms. For now, we're just looking at identifying the growing, shrinking patterns, right? We're looking to identify them, describe them through our pattern rules, and then extend the pattern, okay? You're going to have some practice questions where it's going to ask you to identify, describe, and extend the pattern, okay? Anybody have any questions right now about this?